Hello viewers, welcome to my channel. This is Dr. Venkateshwarlu, Assistant Professor of Physics, Government Degree College, Hyderabad. Now I am going to discuss the topic equation of motion under a central force. It is also called as equation of the central orbit. So let us consider a particle is moving under the central force. So when the particle is moving subjected to the central force, it is having only the radial acceleration. Hence, its tangential acceleration is equals to 0. We know that the radial acceleration is equal to minus p, that equal to square r by dt square minus r d theta by dt whole square. Okay. So where negative sign indicates that acceleration is opposite to the r cap, where r cap is the unit vector away from the center along the radius vector. Right. Now the tangential acceleration at is equals to 1 by r d by dt of r square d theta by dt. That should be equals to 0. Because here the particle is moving under the central force, there only the force acting on the particle is along the radius towards the center, that is the radial force. Hence it is having the radial acceleration. It doesn't have the tangential acceleration. The expression for tangential acceleration at is equal 1 by r d by dt r square d theta by dt equal to 0. So from this d by dt of r square d theta by dt equal to 0, r square d theta by dt is equal to constant, that is I am saying h. Okay, so from this I am writing d theta by dt is equal to h by r square, that equal h u square, where I have taken the substitution r is equals to 1 by u, or u is equal to 1 by r. Okay, this is the equation 2. Equation 2. Okay, now right now u is equal to 1 by r, right? Differentiating this with respect to time, du by dt equal minus 1 by r square dr by dt. Okay, again from this I am writing dr by dt as the subject, dr by dt equal minus r square du by dt, that equals to minus 1 by u square du by dt. Since r is equals to, we have 1 by u. So then this is equal minus 1 by u square. This du by dt can be written as du by d theta into d theta by dt, that equal to minus 1 by u square du by d theta, but d theta by dt equal to what we have, h u square. So that is substituted here, equal to u square cancel, equal to minus h du by d theta. Again differentiating this with respect to time, one more, then on the left hand side we get d square r by dt square, that equal d by dt of minus h du by d theta equal to minus h d by dt of du by d theta. Again this is I am rearranging this expression, then we get minus h d by d theta into du by d theta by dt. Okay, that equal minus h d square u by d theta square into d theta by dt is equal minus h d square u by d theta square into d theta by dt, that is we have h u square substituted here, h into h square, so that this gives minus h square u square d square u by d theta square. Okay, now Let us move the derivation further. So from equations 1 to 4, so what we get? We have the radial acceleration. What is that? Minus p is equal to uh, minus p equal to d square r by dt square, d square r by dt square minus r d theta by dt whole square. Okay, we got the expression for d square r by dt square and d theta by dt whole square. So these values substituted in this equation, then we are getting uh, d square r by dt square equal to this one minus h square u square d square u by d theta square minus r is equal to 1 by u, right? D theta by dt we have h square u square, d theta by dt whole square, h square u power 4 equal to minus p. Okay, so from this, uh, what can we write? D square u by d theta square plus u is equal to p by h square u square. Okay, so both sides minus gets cancelled, right? H square u square taking common, d square u by d theta square plus plus h square u square taking common, plus uh, so then finally we get the equation d square u by d theta square plus u equal to p by h square u square. Okay, so from this expression we are writing d square u by d theta square. So there we are taking common h square by u square, then d square u by d theta square. Okay, then by taking h square u square common, there u square, so u is there equal to p. Next step, d square u by d theta square plus u is equal to p by h square u square. This is the required expression. This equation represents the equation of motion of the particle moving under the central force. Okay, now the same equation of motion can be expressed in terms of total energy and potential energy terms also. So that is, let us see here. Yes. So consider a particle is moving under the central force. That mathematical expression we know, F bar equal to F of R into R cap. Let capital T, V, E be the kinetic energy, potential energy, and total energy of the particle per unit mass respectively. Capital T stands for kinetic energy per unit mass. V stands for potential energy per unit mass. Okay, and capital E stands for total energy per unit mass. We have the formulas kinetic energy of the particle of mass half mv square. Then kinetic energy per unit mass would be T is equal to half v square. That equal to half, where velocity is equal to this formula dr by dt r cap plus r d theta by dt theta cap. Squaring that, you take v bar dot to v bar. So by doing that, v square equal to dr by dt whole square plus r d theta by dt whole square. Say equation 1. But we have dr by dt equal to minus h du by d theta. So in the previous derivation, we got that expression dr by dt equal to minus h du by d theta and d theta by dt equal to h u square. Okay, these two values substituted in equation 1. Then we get t is equal to half dr by dt whole square h square du by d theta whole square plus r, that is r d theta by dt whole square equal r square d theta by dt whole square. R square is 1 by u square d theta by dt, since we have h square, d theta by dt whole square is equal to h square in power 4 substituted. Then that equal to of h square use du by d theta whole square plus h square u square. Okay, h square u square. So let us draw this. Next, then P is equal to of h square du by d theta whole square plus h square square equal to h square taking common of h square du by d theta whole square plus q square. But total kinetic energy equal to total energy minus potential energy. By doing that, E minus V equal to of h square du by d theta whole square plus u square. Right? So from this, writing the square, the terms in the square bracket as a subject. So right hand side we have du by d theta whole square plus u square is equal to. So left side we get 2 into e minus v by h square. This is the equation which represents uh, the equation of motion of the particle moving under the central force in terms of total energy and potential energy. General equation, what is that? Du by d square u by d theta square plus u is equal to p by h square u square. So this equation is in terms of total energy and potential energy of the particle moving under the central force. Here du by d theta whole square plus u square equal to 2 into e minus v by h square. Okay, you should remember that. So when you are writing the equation, there you should know each and every term. In the equation d square u by d theta square plus u equal p by h square u square, where u is equal to 1 by r is the radius vector, and p is equal to the force per unit mass. So, for example, if you take the example, a planet is moving around the sun. Here, the gravitational force between the planet and the sun is the example for the central force. In this case, P is equal to gravitational force acting on the planet per unit mass. What is the gravitational force between the planet and the sun? That is equal to G capital M small m by r square. From that you can write F by m. So the force by mass of the planet is equal to capital G capital M by r square. Capital M is the sun mass. So that you have to understand. P is the force per unit mass. Force per unit mass. U is equal to 1 by r. The equation of motion d square u by d theta square plus u equal p by h square square. Okay. So this is a very, very important topic. So particularly the semester and examination.